This lesson is about the equations of lines in the coordinate plane. The objective is to graph and write linear equations. Hopefully this is going to be a review for what you've already learned in Algebra 1 about writing equations of lines. Under the vocab, the first vocabulary word is slope. Slope is usually represented by the letter, a lowercase m. So the slope m of a line is the ratio, which means a ratio is a fraction. It's a ratio of the vertical change, which we sometimes call the rise, to the horizontal change, which is the run, between any 2 points. So if we look at the formula for slope, m is equal to rise over run, which is the change in your y-coordinates, y2 minus y1, over the change in your x-coordinates, x sub 2 minus x sub 1. Second definition is slope-intercept. The slope-intercept form of an equation of a non-vertical line is y equals mx plus b, where again m is the slope and b is the y-intercept. And we will use that in an example in just a minute. The next third definition is point slope. The point slope form of an equation of a non-vertical line is y minus y1 is equal to m times x minus x1, where again m is the slope and x sub 1, y sub 1 is a point on the line. So let's look at this problem 1 over on the right. In problem 1, we're finding the slopes of lines. So we need to find the slope of line A and the slope of line B. On a graph, it's usually easiest to find slope by counting the units on the graph. The vertical change is the rise, and the horizontal change is the run. So let's look at the slope of line A as the rise over the run. So if we look at a point on line A, we'll look at the point that's -2, -3. So we want to know what is the vertical change and the horizontal change to reach the other point on the line, which is 1, 3. So let's count the units to go up. That's a positive change in y. And then to go right is a positive change in x. So we had to go up 1, 2, 3, 4, 5, 6 units. So the rise is 6. And then we had to go right 1, 2, 3 units. So the run is 3. And so we'll write the slope as 2. The slope of the line is 2. But we could have also used the formula. Instead of counting, we could calculate the difference between the y values. So we have a -3, that's the first y value, minus 3, that's the second y value. And since I started down with the point -2, -3, I have to go back down to that point to get the x value for the denominator. It's -2 minus the x value of the other point, which is 1. So that gives us a -6 over a -3, which is a +2. So the next line that we have is a horizontal line, line B. So let me change colors for it. On line B here, we can pick any 2 points on the line if we wanted to calculate. So if we wanted to calculate the slope on this one, we could find a couple of points and do the calculation with the slope formula. But any horizontal line, the slope of any horizontal line, here it's line B, is going to be 0 because it's a horizontal line. Now if it had been a vertical line, the slope would have been undefined. But any horizontal line, the slope is 0. Let's just see how this works and why it is 0 for a horizontal line. This point, one of the points on the line here is 1, -2, and then the other point is 3, -2. So if you put that in the slope formula, let's calculate this slope as the difference between your y values is -2 minus a -2, which is +2. And then the difference between your x values is 3 minus 1. So we have 0 over 2, which is 0. Like I said, it's okay to have a 0 in the numerator. It's not okay to have a 0 in the denominator, which is why vertical lines are undefined slopes. So now let's look at problem 2. In problem 2, we're going to graph a couple of lines based on the equation of the line. The first graph is y equals 1/2 x minus 1. And so you just need to compare that to your slope-intercept form, y equals mx plus b. So m is equal to 1/2, and b is equal to a -1. So let's go over to the left side of the page to graph that one. So on this graph of y equals 1/2 x minus 1, we said that m, the slope, is 1/2, and that your y-intercept is -1. So plot the y-intercept first. So it intercepts or crosses the y-axis at y is -1. So that's your starting point for the graph. From there, you're going to use rise over run. Your rise, or your vertical change, is 1, up 1, so it's a +1, you go up, and then the run is a +2 to the right to get your next point. So you can do that for several points. You go up 1, right 2, and up 1 and right 2 until you have enough points to make a straight line. And then you can draw your line to graph it. In problem 2b, we are going to graph y minus 2 equals a -2/3 times x plus 4. So you need to compare that to the slope, the point slope form of your equation of a line, which is y minus y1 equals m times x minus x1, where m is the slope and the x sub 1, y sub 1 is a point on the line. So here, the slope of this line is going to be a negative 2/3. Now your negative can go with the numerator or the denominator, one or the other. So I'll let that one go with the numerator. And that, once again, is going to be your rise over the run for your line, your vertical change over your horizontal change. The point on the line where you're going to start, the x sub 1 comma y sub 1 is equal to, the x sub 1 is going to be a negative 4. Be careful of your signs, because this is really x minus a negative 4 to match the point slope formula. And then the y value for y sub 1 is going to be a positive 2. So that's the starting point for your line. So plot, the x is negative 4 and y is 2 on your line. That's the starting point for your graph. Now you're going to use the rise and the run to do the rest. So the rise is a negative 2. So from this point, I'm going to go down 2, since it's negative, and then I'll go right 3, since it's a positive 3 in the denominator. And I can continue to go down 2 and right 3, and down 2 and right 3, until I have enough points that I can draw the line through those points. And that is the graph of the equation. Y minus 2 is equal to negative 2/3 times x plus 4. In problem 3, we're writing equations of lines. Problem A asks, what is the equation in slope-intercept form of the line with a slope of 2 and a y-intercept of 4? So let's use our slope-intercept form of a line. Y equals mx plus b. And we're going to just substitute in the slope of 2 for the m. And for b, we're going to put in the y-intercept of a positive 4. And that's all that you have to do to write the equation of that line. In problem B, what's the equation in point slope form of the line that passes through points 3, negative 7 with a slope of 1? So write your point slope form of a line. Y minus y1 is equal to m times x minus x sub 1. And let's put in, it passes through the point x comma negative 7. That is your x sub 1 comma y sub 1 point that goes into your equation. So y minus a negative 7 is y plus 7, because the two negatives become a positive. The slope of the line is negative 1, so that goes in for the slope of m. And then your x coordinate, your x sub 1 coordinate is 3, so you have x minus 3. And that's all you need to write for the equation in point slope form of that line. In problem 4, we're using 2 points to write an equation. So here we're given, write the equation of a point slope form for the line graphed. So since we only have 2 points, but we have a graph, we have 2 points, but we need the slope of the line. So the slope of the line is rise over run. And we can calculate that, or we can count that, since we do have a graph. So to go, be careful, because this graph is going by units of 2 on the scale. Okay? So we have 2, 4, 6, 8, 9 is what it's going up. The rise is 9. And then it's going to the left 2, for 6. So a move of left of 6 is a negative 6. So that means that our slope of the line is a negative 3/2, simplified. So let's look at how to write this equation with the point slope form. The easiest equation to use when you know the slope of the line and one point is a point slope form of the line. So y minus y1 is equal to m times x minus x1 is the point slope form of the line. So let's substitute in, let's use the first point, the negative 2 comma 5. So if I substitute in 5 for the y sub 1, I've got y minus 5. I'm putting in the negative 3/2 that we calculated for the slope, or counted, and then the x-coordinate is a negative 2, so y minus a negative 2, x minus a negative 2 is x plus 2. That is a valid equation for that line, but we could have also used the other point, the 4 comma negative 4 point. So I'm going to say, or I could have written the other equation as y minus a negative 4, because negative 4 is the y-coordinate of the other point on the line that we have. So y minus a negative 4 is y plus 4. Still the same slope of a negative 3/2. And then I would have used the x is equal to 4. So x minus 4. Both of those equations are valid equations for that line. And if you simplify those equations down to y equal mx plus b format, then you would have the same equation exactly. In the last problem, we're writing equations of horizontal and vertical lines, and it wants you to write the equations for the horizontal vertical lines through the point 1 comma 7. So let's sketch the graph of these lines. So we have an x and a y axis, and I want to plot the point (1, 7). So 1, 7. And then I'm going to sketch the lines. The horizontal line that goes through that point is the line where every value on that line, y is equal to 7, no matter what x is on that line, y is always going to be equal to 7. So the equation of that line is y equals 7. And so that's the horizontal line. And then the other line that we have through that is the vertical line. So the vertical line through that point, every point on that line, x is 1. Y changes, but x is always going to be 1. So the equation of the line is x equals 1. And so that's the equation of the vertical line through the point 1, 7.